Good morning, everyone. This is one more session with respect to Linux system programming. In this session, we need to discuss one concept called record lock, or also called as a file lock concept. So, before starting with the today's session, if my voice is clear as well as able to see the screen properly, please type 1 in the chat box. If my voice is clear as well as able to see the screen properly, please type 1 in the chat box. Okay, thank you very much. If you're able to recollect what is the discussion happened in the last session, will you agree? In the last session, we are trying to understand little bit more about the shared memory concept. Again, in the last session, we are trying to understand little bit more about shared memory concept. Now, can you tell me what is the difference between SHM get and SHM80? What is the difference between SHM get and SHM80? Will you agree? SHM get is used to create a shared memory segment. In which space? It is used to create a shared memory segment. In which space? User space. And SHM get returns an ID. SHM80, what it will do, this shared memory segment is mapped with your process. SHM80 is used to attach the shared memory segment to your process. So whenever you use SHM80, can I say in your heap section, so same memory is allocated. Internally, I told you one concept called mmap, memory map concept. So memory gets mapped between the shared memory segment and user process memory. And one thing we observed in a SHM in a shared memory, it is a faster. Why? Because it is a fastest IPC. Why? Because everything data transferring and data receiving is going on in a user space only. Will you agree? It is a faster. Why? Because data transmitting and data receiving is going on in a user space only. No involvement of no involvement of shared memory manager. Once it is attached to us, our responsibility. Second reason why it is called as a faster, internally there is no synchronization mechanism. Internally inbuilt, there is no synchronization mechanism. That is the reason. That is the reason this is called as a fastest IPC. That is the reason this is called as a fastest IPC. I told you when one process, the disadvantage of the shared memory yesterday when I'm talking. So this is a transmitter process. This is the receiver process. Suppose transmitter is not yet kept the data into the shared memory. If receiver receives, can I say receiver receives the junk data? Suppose transmitter transmitter before putting the data into the shared memory, if the receiver receives, receiver will receive old data. Second drawback we are trying to understand. Second drawback we are trying to understand about this shared memory. If multiple processes are writing the data into the shared memory, can I say the data gets mixed there? If multiple processes are writing the data into the shared memory segment, can I say the data gets overwritten or truncated or disturbed it? Not a proper order, the data will be there in the file, in the shared memory. To overcome this, to synchronize these things, I told you we need to use the concept called semaphores. But yesterday we are not yet started the discussion of the semaphore. Yesterday we started thinking about the file lock are also called as record lock. Do you agree? Yesterday we are not yet started with the discussion of the semaphore. Yesterday we are trying to understand, we are not yet discussed, that is called as a file lock or also called as a record lock. To understand this, I written the two programs. I don't know you remembered or not. One is a w1.c, one is a w2.c. I written a two programs. What is the first w1.c is writing? Small a to small z. What is the w2.c is writing? Capital A to capital Z into where? Small a to small z, capital A to capital Z into where? Can I say into the file? Can I say file is a common resource? Common resource means multiple processes can access that resource. File is a common resource, meaning is multiple processes can access that resource. So when this process is also putting the data, then this process is also putting the data at a time. Can I say here small a to z, capital A to z gets mixed? Can I say small a to z and capital A to z gets mixed? Then I told you we need to synchronize them. We need to synchronize them. I told you for this, for file synchronization, there is a concept called file lock. There is a concept called file lock, also called as a record lock. There is a concept called file lock, or also called as a record lock. So I told you this record lock can be done using one function called what is it? Using one function called what is it? What is the name of the function? This record lock can be done using one of the function called functl. So our discussion will be, today's discussion is how to lock the file using functl so that so that other process so that other process cannot write when one process is already writing. Observe, today's topic is today's discussion is how to log the file using functl so that other process cannot write when one process is already writing into that. Other process cannot write when one process is already writing into that. Using which concept? Using the record lock or file lock functl. Now, yesterday, I don't know you remembered or not, one more concept we are trying to understand, that is called critical section of code. Yesterday, we are trying to understand one more concept called critical section of code. What is the meaning of critical section of code? I told you the critical section of code is nothing but the part of the program where we are trying to access the shared resource. Observe, vi w1.c, the part of the program where we are trying to access the shared resource. Can I say this portion is called as critical section of code? This portion is called as critical section of code where we are trying to access the file common resource. Now logically think here we need to lock the file. Here we need to lock the file. Now here we need to unlock the file. All of you are getting the point? So the arrow mark which I before for loop we need to lock the file. Before for loop we need to lock the file, and after for loop, once the work is completed with a file, we need to unlock the file. If I accept this statement, type 2 in the chat box. If I accept this statement, type 2 in the chat box. Okay. Using which function we need to do this work? Using which function we need to do this work? Using fcntl function. So what I will do is I'll open the man page of fcntl. I don't know you remembered or not. fcntl I used in a pipe concept also. I don't know you remembered or not. fcntl I used in a concept in the file pipe. Now observe here. How many arguments we need to pass to fcntl? How many arguments we need to pass to fcntl? 1, 2. Remaining arguments are variable arguments. Minimum 2 arguments we need to pass. Again, we need to pass 2 arguments to fcntl. Again, we need to pass 2 arguments to fcntl. Can you tell me what is the first argument? Can you tell me what is the first argument? We need to pass minimum 2 arguments to fcntl. What is the first argument? Will you agree the first argument is a file descriptor to which file you want to lock. To which file you want to lock. The first argument is the file descriptor. Second argument is what? I'll write it here. The first argument fcntl return type is int. fcntl, the first argument is what? File descriptor. And the second argument is what? Second argument is what? Command. And third argument onwards, variable arguments. First argument is file descriptor. Second argument is a command. The third argument onwards is what is it? Third argument onwards is variable argument. Third argument onwards is a variable argument. What is that command we need to use for this particular purpose? What is the command we need to use for this particular purpose? Observe. What is the command we need to use for this particular purpose? All of you observe here. The command argument, one you can use f underscore, one you can use f underscore set lk. F underscore set lk. Command argument. F underscore set lk. What is the meaning of this? We are interested to set lock. If I set the command as f underscore set lk, the meaning is we are interested to set the lock. If this information, this point is clear, type C in the chat box. The command is any one of the command. One command is f underscore set lk. We are interested to set the lock. Second is f underscore set lk w. Second is f underscore set lk w. Second is f underscore set lk w. The meaning of this is we are interested to set the lock if lock is not available. wait for the lock availability. If lock is not available, wait for the lock. Now tell me, for our particular problem statement, is f underscore set lk is preferable or f underscore set lk w is preferable? Again, if somebody is already locked, my process should wait for the lock availability. Again, if somebody is already locked, suppose P1 process is already locked file, P2 process should wait. So can I say for our particular problem statement, for our particular problem, we need to go for set lkw. We need to go for set lkw. One more command is f underscore get lk. One more command is f underscore get lk. Can you tell me what is the use of this? To get the lock information. F underscore get lkw to get the lock information. If somebody is already locked, if you want to know who locked it, if somebody is already locked, if you want to know who locked it, you can use get lkw. Again, if somebody is already locked, if you want to know the who locked it, then you need to use get lk. So in these three, one of the command we need to use it depends upon our requirement. For our requirement, whatever we are problem solving, we need to use this command f underscore set lkw. So I'll use that here. Sorry. I'll use that here. Just a minute. So vi w1.c. Now I need to use after this printf before fcntl. What is the first argument? fd. Second argument f underscore set lkw. Second argument is set lkw, and third argument is lock information you need to pass. Third argument is information about the lock you need to pass. Now tell me, when I'm executing this program, if before is printed, after is not printed, what we need to assume? Suppose when I'm executing this program, before is printed, after is not printed, what is the meaning? Suppose this before is printed, but this after is not printed, what is the meaning? Can I say this is blocking? Suppose before is printed, after is also printed. Can I say it is entered into the critical section of code? Suppose before is printed, after is also printed immediately. Can I say it entered into the critical section of code? It entered into the critical section of code. Now you may get a doubt, sir, what is that V? V is a lock information. We need to create one struct flock V. Will you agree? V is a variable of one structure called flock structure. We need to fill the information about this structure, these members. Again, V is a variable of what is it? One structure. The name of the structure is flock structure. All of you are observing A flock structure contains these many members. A flock structure contains these members. All of you are getting the point? A flock structure contains these members. We need to fill these members. Then we need to pass the lock information. We need to fill these members and we need to pass the lock information. We need to fill these members as per our requirement. We need to pass that information. So I'll write it here. Third argument. Third argument. We need to pass address of flock structure. Flock structure variable. Third argument is we need to pass the address of a flock structure variable. So what we need to do? Struct a flock one variable. Can I say this is a auto storage type? Will you agree? When you declare a local variable, that is a auto storage type. By default, it contains some junk data. So this is an auto storage type. By default, it contains the junk data. Will you agree? So we need to fill the members. What are the members are there? What are the members are there in that flock? What are the members are there in that flock structure? I'll open it. What are the members are there in the flock structure? This is the members of flock structure. This is the members of flock structure. So first member is what is the first member? L underscore type. V dot L underscore type of the lock. Just give me 1 minute. V dot L underscore type. Which type of the lock you need to make? Can you select one of the lock type? Can you select type of the lock? Is it a read lock, a write lock, or unlock? If you are writing, others should not. If you are writing, others should not. Now, which type of lock you want to make to that file? Which type of lock you want to make to that file? Can I say I need to go for write lock so that other process should not write? Directly I'll write it here. Directly I'll write it here in this program. V dot L underscore type is equals to V dot L underscore type is equals to which lock? F underscore WRLCK. F underscore WRLCK means I'm putting a writing lock. F underscore WRLCK. Next argument is what? Whence. All of you are observed this SEK underscore set CUR, and in a fseek function we use this. I hope all of you can recollect this. In a fseek function we use this whence parameter. SEK underscore set means SEK underscore set means SEK underscore set means from the beginning. SEK underscore CUR means from the current. SEK underscore end means from the end. For our requirement, SEK underscore set. V dot L underscore whence is equals to SEEK underscore set. SEK underscore set. What is the next argument? Start. Start length, both I'll give it as a 0. We'll discuss what is the meaning of those two later. So v dot L underscore start is equals to 0. V dot L underscore len is equals to 0. After that functl function. Will you agree? We are creating the structure variable. We are filling the members of the structure. And we are passing it here. We are passing there. So what is the command you used here? What is the command we used? Set lock set lkw. I'm interested to set the lock. If the lock is not present, wait for the lock availability. If the lock is not present, wait for the lock availability. And which type of lock I am making? Write lock. And total file, that is the reason start and length I'm making total as a 0 and 0. Suppose if file is already locked by some other process, can I say this function will block? Suppose if file is already locked by some other process, can I say this function will block? Will you agree? That function will block. Suppose if file is already locked by some other process, if a file is locked by some other process, can I say this functl will block? Now tell me, after writing, what is the next step? You need to release the lock. Now tell me, once you enter into the critical section of code, after writing the data into the file, what is the next step you need to do? What is the next step we need to do? Can I say we need to release the lock? Will you agree? After completion of writing the data into the file, will you agree? We need to release the lock. Will you agree? We need to release the lock. Please reply. Now tell me, v dot L underscore type. We need to release the lock. Can you tell me which type of lock I need to put? Which type of lock I need to put? Will you agree? Unlock. Which type of lock I need to put? Will you agree? Unlock. F underscore unlck. F underscore unlck. Now will you agree? Here you are updating the local variable. Using functl, again you need to set the lock. Functl fd comma f underscore set lk comma ampersand of v. Now I need to tell you an important point here. Here you are using functl for locking purpose. Here you are using functl for unlocking purpose. Again, in the first functl function call, is for locking purpose. Next functl function call is for unlocking purpose. Now tell me, here I am setting the lock. Which type of lock I am setting? Here I am setting the lock. Which type of lock I am setting? Here I am setting the lock. Which type of lock I am setting? Can I say I am releasing the key here? Will you agree? In a simple way, if I say I am releasing the key here, unlocking it. So our work is done. We need to see. Our work is done. So cc w1.c hyphen o w1 cp w1.c w2.c vi w2.c. In a w2.c, what I need to do? Small a to small z or capital A to capital Z? In a w2.c, what I need to do? Capital A to capital Z. Just I need to change this code like this. Capital A to capital Z. Remaining code is same. cc w2.c hyphen o w2. Now observe. Will you agree? Two programs are ready. One is a W1 program, one is a W2 program. Will you agree? Two programs are ready now. One is a W1 program, one is a W2 program. So W1 program is going to write W1 program is going to write W1 program is going to write just be8f1. Please wait. Let me finish. Let me show you this. After that, I'll show you. I'll discuss your questions, whatever it is. Now observe. First, I am removing the data file. Now observe. Dot slash w1 before after dot slash w2. Observe. W1 process is printed before and after, but W2 is printed before. Can I say here FCNTL is blocking? B8F1. Will you agree? There FCNTL is blocking. There FCNTL is blocking. Now observe. Now observe, when this is printed done, can I say it is entered into the critical section of code? Now observe, when this is printed done, this is entered into the, here FCNTL is unlocked because key is available at that moment. Now can I say now this process is writing the data into the file. Now both are done. Both are done. Now if I open the file, observe, first small a to small z, next capital A to capital Z. If I open the file, are you observing first small a to small z, later capital A to capital Z? But in a previously, what happens? Previously, what happens? Can I say previously the data gets mixed there? Previously, the data gets mixed there. Data gets merged or data gets mixed. Will you agree? Previously, data gets merged or data gets mixed. So now, between two processes, we synchronized using FCNTL. Now the questions. B8F1, now you can ask it. What your question? Now I'll try to address. Otherwise, I'll wait. I'll see your question. So your question is, just a minute. I'm unable to get. B8F1, is clear, or should I read the question? I don't have the mouse. That is the reason I'm getting a little bit difficulty. Just give me 1 minute of time. Sir, the process which is locked the file, only that process have the permission to unlock? Yes, definitely. So the process which is locked the file, as per the normal process, normal scenario, the process which is locked, only that process need to unlock. Other process is trying to unlock, that cannot be unlocked. Getting the point? The process which is locked, only that process need to unlock. Other processes cannot unlock if they are trying to unlock it also. If they are trying to unlock it also, other processes cannot be unlocked. Is that point is clear? The process which is locked, only that process need to unlock it. Only that process need to unlock it. Now observe the program, what we are trying to do in this program. Just a minute. Now this program is small a to small z. Just I'll set the line numbers. Now observe what we did in a line number 16. Can you tell me what we did in a line number 16? What we did in a line number 16? Will you agree? We created a variable for one structure called flock structure. We created one variable for one structure. The name of the structure is flock structure. Flock structure. Now 3 dots means this FCNTL is used for multi-purposes. DE9A3, try to understand. This FCNTL is useful for multiple purposes. This FCNTL is useful for multiple purposes. So, first 2 arguments must and should be. Remaining arguments depends upon the purpose you are using FCNTL. You need to use that. DE9A3, got the point? First 2 arguments must and should. Remaining arguments here for that purpose. I don't know you remembered or not. When we are dealing with pipe, we created a pipe using the pipe system call. When we create a pipe, both ends will be acts as a blocking. When we create a pipe, normally both ends will block. Now, if you don't want to block, you can go for FCNTL, and first argument is P of 1, second argument is F underscore set FL, third argument is O underscore non-block. I don't know you remembered or not. This we discussed it. Third argument is O underscore non-block. Now can I say this FCNTL is for multi-purposes? FCNTL can be used for locking purpose. FCNTL is useful for setting the flags also. So that's what. 3 dots means variable argument list function. Now can you tell me this which lock I am setting here? Right lock. A seek underscore set means from the starting. 00 means total file. Now this sometimes it will block, sometimes it will not block. Sometimes it will block. Sometimes it will not block. Now tell me what is the meaning of sometimes it will block? Suppose lock is not available. Can I say it will block? Will you agree? What is the meaning of sometimes it will block? Can I say if lock is not available, it will block? If lock is available, it will not block. If lock is not available, can I say it will not block? Now after, now can I say which function here deciding to enter into the critical section of code or not? Which function here deciding to enter into the critical section of code or not? Can I say FCNTL is deciding to enter into the critical section of code or not? Now here FCNTL function is deciding to enter into the critical section of code or not. Now when my work is completed, what is next job? When my work is completed, I need to unlock. You may get a doubt, sir. If I don't do this, what happens? If I'm not doing this, what happens? If you don't do this, when your process is terminated, automatically gets unlocked. Again, if you don't do this, when your process is terminated, automatically gets unlocked. Again, if you don't do this, if a process is terminated, automatically it gets unlocked. Is that point is clear? When the process is terminated, automatically it gets unlocked. If a process is not terminated, suppose if your process is not terminated, suppose if your process is not terminated, so can I say unlocking is not going to happen? Suppose if a process is not terminated, will you agree? The other process still blocked only. Will you agree? The other process still gets blocked only. So our responsibility is our responsibility is whenever you are locking, once your work is finished, we need to, whenever you are locking, once your work is finished, you need to unlock it. Correct. Our responsibility, whenever you are locking, after work is finished, you need to unlock it. Is that point is clear? This is what? Record locking using, this is the record locking using FCNTL. This is a record locking using FCNTL function. If this is clear, I'll share these programs in the LMS. Later you can check it out. If this is clear, type C in the chat box so that we'll discuss next concept called semaphores. If this is clear, type C in the chat box so that we'll discuss the next concept that is called semaphores. So if somebody asks what is a semaphore, if somebody asks what is a semaphore, we need to say semaphore is one of the IPC mechanism. What is semaphore? Answer is it is one of the IPC mechanism which is used to synchronization purpose. Now can you tell me, till now whatever the IPCs we discussed it, called pipe, named pipe, message queue and shared memory, those are also IPC mechanisms. But those IPC mechanisms is for what purpose? Again, till now we discussed some IPC mechanisms like pipe, like named pipe, like what you called pipe, named pipe, message queue, and shared memory. Those are also IPC mechanisms. For what purpose those IPC mechanisms? Those IPC mechanisms are for data transferring between the processes, communication purpose. Now, this IPC mechanism, what we are discussing now, this is also used to communicate between the processes, not for exchanging the data. This is for not for exchanging the data. This is for synchronization purpose. Again, try to understand the difference between IPCs till now we discussed. Now, whatever we are discussing, till now, whatever the IPCs we discussed it, those IPCs is for exchanging the data between the processes. But this IPC is not for data exchange. This is for this IPC is not for data exchange. This IPC is for what? Synchronization purpose. If this point is clear, type C in the chat box. This IPC, whatever we are going to discuss, it's not for data exchange purpose. This IPC is for synchronization purpose. Synchronization between what? Synchronization between what? Can I say synchronization between multiple processes when they are trying to access shared resource? Will you agree? Synchronization is for what? Synchronization between multiple processes when they are trying to access the common resource. Will you agree? Using this IPC mechanism, we cannot transfer the data. Using semaphores, we cannot transfer the data. So what is a semaphore? Semaphore is one of the IPC mechanism which is used to synchronize between the processes when they are trying to access the common resource, which is used to synchronize between the multiple processes when they are trying to access the common resource. When they are trying to access the common resource. Is it clear? No. One more definition of semaphore. Semaphore is a small positive integer which is present in kernel space, which is used to synchronize between multiple processes when they are trying to access common resource. Semaphore is a small positive integer which is present in the kernel space, which is used to synchronize between multiple processes when they are trying to access the common resource. Okay, try to copy these statements in your notes. Semaphore is a small positive integer which is present in a kernel space, which is used to synchronize between multiple processes when they are trying to access the common resource. When they are trying to access a common resource. So the functions involved in this IPC mechanism is next point. Functions involved in this IPC is semget, semctl, semop. Semget function, semctl function, semop function. Again, the functions involved in this IPC mechanism is semget function, semctl function, and semop function. Semget function is used create and open the semaphore set. Semctl is used to do some control operations such as setting value, getting value, etc. Semctl function is used to do some control operations. Semctl function is used to do some control operations such as setting the semaphore value and getting the semaphore value, etc. etc. Semop function is used to this function decides the process should enter into critical section of code or not. Now, can you tell me just now whatever the topic we discussed, in that topic, which function decides my process should enter into the critical section of code or not? Can you tell me just now whatever the function, whatever the concept we discussed it, in that which function decides the process should enter into the critical section of code or not? Can I say fcntl? Will you agree? fcntl. Now, in this concept, which function decides this concept? Which function decides it should enter into the critical section of code or not? Can I say semop function? In this concept, which function decides the process should enter into the critical section of code or not? Can I say semop function? So, what I'm going to do is to understand this topic easy. I'm going to divide three parts. Again, to understand this concept easy, this topic easy, I'm going to divide this topic into three parts. Part 1, how to set semaphore value. Part 2, how to get semaphore value. Part 3, how to do semaphore operations. When which condition my process will enter critical section of code, and when my process gets blocked. Okay, to understand this concept, I'm going to divide it into 3 parts. In the first part, what I'm going to discuss? In a first part, what I'm going to discuss? In a first part, I'm going to discuss how to set the semaphore value. In a first part, I'm going to discuss how to set the semaphore value. In a second part, I'm going to discuss how to get the semaphore value. In a third part, I'm going to discuss some semaphore operations. When my process will enter into the critical section of code, when my process will not enter into the critical section of code, that thing I'm going to discuss in the part 3. Is that is clear? Is this is clear? Type C in the chat box. To understand this topic little bit easily, I'm going to discuss this in a 3 different parts. In the first part, I'm going to show you how to set the semaphore value. In the second part, I'm going to show you how to get the semaphore value. In a third part, I'm going to show you how to do the semaphore operations, so that when my process will enter into the critical section of code and when my process execution gets blocked, these things I'm going to show it in this third part. Okay, so what I'm going to do is, so this discussion I'm going to do it in the Monday session. Again, this discussion I'm going to do it in the Monday session. Monday morning 7:30 to 9 will be there, one session. And if topic is not completed, I need to take one more session 4 o'clock. In one day, we need to discuss the semaphore concept. Again, Monday from 7:30 to 9, we'll discuss it. If time is not permits, if still pending concept is there, extra session I need to conduct at 4 o'clock. Is this point is clear? Is this point is clear? Type 1 in the chat box. Okay. So now I'm going to wind up this session. Those 2 programs and this file I'm going to put it in the LMS with the today's date. Those 2 programs and this file I'm going to put it in the LMS with a today's date. Is it clear? I'm going to wind up the today's session. Those 2 programs and this file I'm going to put in LMS with a today's date. Thank you very much. Thank you very much.